Okay, I wanted to do a quick video on dividing rational expressions. Now, this is kind of a continuation of the previous video with the multiplying rational expressions. And the only difference is that we are going to take this division problem and turn it into a multiplication problem, but dividing is the same as multiplying by the reciprocal. So let me show you what I mean by that. So when I say reciprocal, I'm going to take this second fraction that we're dividing by, and we're going to take the reciprocal of it. Now, remember from way back when you learned about reciprocals, reciprocal is the multiplicative inverse, or the fraction that you multiply by to get 1. So really, the reciprocal is just taking the numerator and the denominator and flipping them over. So what I'm looking at now is going to be 10x cubed plus 100x squared over 6x squared minus 48x, just like what we had to start with. But now I'm turning it into a multiplication problem, and this is when the reciprocal happens. I'm switching the denominator and the numerator. And now I can treat this problem as a multiplication problem. Super important that you do this before you start factoring or canceling anything out. Because if you forget and you leave it like this and you try to cancel some tops and bottoms before you flip the fraction over, it's going to mess up your entire problem. So go ahead and do this, turn into a multiplication problem of the reciprocal, and then you could start doing your factoring and going on from there. All right, so now I'm just going to work this problem out. So I'm going to just factor each of the four parts, and then we'll see if anything can cancel out. There is a greatest common factor of 10x squared in the top here. So that's going to leave me with an x plus 10. There's a greatest common factor on the bottom of a 6x, and that's going to leave me with x minus 8. Okay, over here in the second fraction, the numerator has a almost, it has the exact same thing. So I'll go ahead and factor it for factoring purposes. But we are going to end up being able to cancel that out shortly. Okay, so greatest common factor of 6x. And then I've got a quadratic trinomial. Lead coefficient is a 1, so that makes my life a little bit easier. I want the factors of 20 that add up to 12. So going to go through that. All the ways to get 20 are 20 and 1, 10 and 2, 4 and 5. Looks like it's going to be x plus 10, x plus 2. And that order there does not matter. So now I'm looking for tops and bottoms that might match. Remember, they don't have to be in the same fraction. All right, so the x plus 10s are the same, they cancel. The x minus 8s are the same, they cancel. The 6x's are the same, they cancel. So then I'm trying to find, and the 10x squared does not match anything on the bottom of any of these other fractions. So I am now left with 10x squared in my numerator and x plus 2 in my denominator. But because this x plus 2 are two different terms, I can't cancel out those x's. So don't make that mistake. Unfortunately, I can't factor out an x here to be able to cancel with anything, and I can't cancel out the 10 and the 2 because, again, I can't factor out a common factor of the denominator, so I just have to stop here, and this is my answer.